Welcome to the Chapter 10 lecture on externalities. Let's start with a quick introduction. Remember Principle 6 from Chapter 1. Markets are usually a good way to organize economic activity. In the absence of market failures, the competitive market outcome is efficient, meaning it maximizes total surplus. One type of market failure discussed in Chapter 1 is externalities, which are the uncompensated impact of one person's actions on the well-being of a bystander. Externalities can be negative or positive depending on whether the impact on the bystander is adverse or beneficial. Self-interested buyers and sellers neglect the external costs or benefits of their actions, so the market outcome is not always efficient. This brings us to principle number 7 from Chapter 1. Governments can sometimes improve market outcomes. In the presence of externalities, public policy can improve efficiency. Here are a few examples of negative externalities in which a bystander is adversely affected by someone else's actions. Air pollution from a factory, a neighbor's barking dog, a loud stereo from a neighbor, noise pollution from a construction project, secondhand smoke, or talking on a cell phone while driving. Let's recap welfare economics that we discussed in Chapter 7 by looking at the market for gasoline. The demand curve shows the private value, the value to buyers, which is the price they are willing to pay. The supply curve shows the private cost, the cost directly incurred by the sellers. Remember that market equilibrium maximizes consumer and producer surplus. Let's now analyze the effect of the negative externality. Since negative externalities impose an external cost on bystanders, the supply curve will shift upward, reflecting the social cost. The external cost is the value of the negative impact on bystanders. Let's assume in this case that the negative impact on gasoline is $1 per gallon due to the harm from smog and greenhouse gases. The socially optimal quantity is 20 gallons of gas, since that is the equilibrium quantity when taking into account the external costs. At any quantity less than 20 gallons, the value of additional gas to consumers exceeds the social cost. At any quantity greater than 20 gallons, the social cost is greater than its value to society. The market equilibrium is 20 gallons, but is greater than the socially optimal quantity of 20 gallons. One solution to this problem would be to tax sellers $1 per gallon, so the supply curve would shift upward by $1. Internalizing the externality is altering incentives so people take into account the external effects of their actions. In our example, the $1 per gallon tax on sellers makes sellers' costs equal to the social cost. When market participants must pay social costs, the market equilibrium will equal the social optimum. Just a reminder from our discussion about taxes in Chapter 8, imposing a tax on buyers would achieve the same outcome. The market equilibrium quantity would equal the socially optimal quantity. Here are a few examples of positive externalities in which the impact on bystanders is beneficial. Vaccinations against contagious diseases not only protect you but the people around you. Research and development creates knowledge that others can use. People going to college raises the population's education level, which reduces crime, makes people better voters, which improves government. In the presence of a positive externality, the social value of the good includes the private value. which is the direct value to buyers, and the external benefit, which is the value of the positive impact on bystanders. The socially optimal quantity maximizes welfare. At any quantity lower than the socially optimal quantity, the social value exceeds the cost. At any quantity higher than the socially optimal quantity, the cost exceeds its social value. In summary, if there is a negative externality, the market quantity is larger than socially desirable. If there is a positive externality, the market quantity is smaller than socially desirable. To fix these problems, we can internalize the externality by taxing goods with negative externalities or by substituting goods with positive externalities. A subsidy is a payment to encourage people to do more of an activity. When looking at public policies towards externalities, there are two approaches: command and control policies and market-based policies. Command and control policies regulate behavior directly. Examples include limits on the quantity of pollution that can be emitted, or regulations that firms adopt a particular technology to reduce emissions. Market-based policies provide incentives so that private decision makers will choose to solve the problem on their own. Examples include corrective taxes and subsidies or tradable pollution permits. Let's discuss corrective taxes and subsidies. A corrective tax is designed to induce private decision makers to take into account the social costs that arise from a negative externality. Corrective taxes are also called Pigovian taxes after the economist Arthur Pigou. The ideal corrective tax would equal the external cost of the negative externality. For activities with positive externalities, the ideal correct subsidy would equal the external benefit. Other taxes and subsidies distort incentives and move the economy away from the social optimum. Corrective taxes align private incentives with social interests, making private decision makers take into account the external costs and benefits of their action and move the economy toward a more efficient allocation of resources. If we compare corrective taxes to regulation, we can see the difference firms have with the different costs of pollution abatement. The efficient outcome occurs when firms with the lowest abatement costs reduce pollution the most. A pollution tax is efficient because firms with low abatement costs will reduce pollution to reduce their tax burden, and firms with high abatement costs will have greater willingness to pay for the tax. In contrast, a regulation requiring all firms to reduce pollution by a specific amount is not efficient. Corrective taxes are better for the environment because the corrective tax gives firms an incentive to continue reducing pollution as long as the cost of doing so is less than the tax. If a cleaner technology becomes available, the tax gives firms an incentive to adopt it. In contrast, firms have no incentive for further reduction beyond the level specified by regulation. Here's an example of a corrective tax on gas. A gas tax targets three negative externalities: congestion, accidents, and pollution. With congestion, the more you drive, the more you contribute to congestion. With accidents, larger vehicles cause more damage in an accident, and with pollution, burning fossil fuels produces greenhouse gases. Tradable pollution permit system reduces pollution at a lower cost. A tradable pollution permit system reduces pollution at a lower cost than regulation. Firms with a low cost of reducing pollution sell whatever permits they can to make a profit. Firms with a high cost of reducing pollution buy permits since eliminating the pollution would be more costly. The result is pollution reduction is concentrated among those firms with the lowest costs. Let's compare corrective taxes to tradable pollution permits. Like most demand curves, firms' demand for the ability to pollute is a downward sloping function of the price of polluting. A corrective tax raises this price and thus reduces the quantity of pollution firms demand. A tradable permit system restricts the supply of pollution rights and has the same effect as the tax. When policymakers do not know the position of this demand curve, the permit system achieves pollution reduction targets more precisely. Let's now look at a private solution to externalities called the Coase theorem. The Coase theorem states that if private parties can costlessly bargain over the allocation of resources, they can solve the externalities problem on their own. It is best to explain this theorem with an example. I'm going to review the same example in the textbook. Suppose that Dick owns a dog named Spot. A negative externality arises when Spot's barking disturbs Jane, Dick's neighbor. The socially efficient outcome maximizes Dick's and Jane's well-being. If Dick values having Spot more than Jane values peace and quiet, the dog should say. The Coase theorem states that the private market will reach an efficient outcome on its own. Let's look at case 1. Suppose that Dick has the right to keep Spot. The benefit to Dick of having Spot is $500, and the cost to Jane of Spot's barking is $800. The socially efficient outcome would be for Dick to get rid of Spot. The private outcome is Jane pays Dick $600 to get rid of Spot, making both Jane and Dick better off. The private outcome is the same as the socially efficient outcome. Let's look at case 2. Dick has the right to keep Spot. The benefit to Dick of having Spot is $1,000, and the cost to Jane of Spot's barking is $800. The socially efficient outcome is for Dick to keep Spot. The private outcome is Jane is not willing to pay more than $800, and since Dick is not willing to accept less than $1,000, Spot stays. Again, the private outcome equals the socially efficient outcome. Let's look at case 3. Jane has the legal right for peace and quiet. The benefit to Dick of having Spot is $800, and the cost to Jane of Spot's barking is $500. The socially efficient outcome is for Dick to keep Spot. The private outcome is Dick pays Jane $600 to put up with Spot's barking. Again, the private outcome is the same as the socially efficient outcome. The lesson from all three cases is the private market achieves the efficient outcome regardless of the initial distribution of the rights. However, private solutions do not always work. The first problem with the Coase theorem is transaction costs. The costs parties incur in the process of agreeing to and following through on a bargain. These costs may make it impossible to reach a mutually beneficial. The second problem is stubbornness. Even if a beneficial agreement is possible, each party may hold out for a better deal. The third problem is coordination. If the number of parties involved is very large, coordinating them to agree may be costly, difficult, or impossible.